If it quacks like a duck, it is a duck. This is one of these phrases people tend to throw out and then make everybody else confused. Let's talk about duck typing. So I can't give you the deep down depths of what it theoretically means. We'll talk about that in another video, but generally speaking, duck typing is about determining the suitability of an object based on what it does rather than what it is. To be even more specific, whether a method can be passed a specific object, i.e. whether the object is suitable as an argument for the method, is commonly, or in a non-dynamic language, determined by the type of the object, i.e. what type the object is of, i.e. what it is. But duck typing says, actually, what does it matter what it is? Let's instead determine whether the object is suitable or not based upon what it does, i.e. what methods it responds to. So in other words, if a method takes an object and then calls the method quack on that object, then as long as the object responds to the method quack, what does it matter whether it's a human or whether it's a duck, right? The common example is a human pretending to be a duck but still responding to the quack method. An interesting parallel I find is to consider the Turing test. You know, the test for artificial intelligence. It seems to me that the test is about sidestepping the question of what is human, because it's philosophically difficult. So instead of attempting to answer the question of what is human and what is not, the question is sort of restated, or the experiment is designed in such a way that that question is ignored. So the Turing test seems to provoke the question of that if something behaves human, what does the question of whether it is human or not, what does that question matter? If it behaves human and we can't distinguish it from an actual human, then what is really the question of whether it's human or not? Now, this is of course almost a kind of far-fetched analogy, but really I find it quite suitable for duck typing. Because duck typing does the same thing. It says, what does it matter what something is? The thing that does matter is how you want to use that object. And if that particular object does in fact respond to all of the methods that you want to call upon it, what does it then matter that it is not stated to be of the type that you expected it to be? So very practically, what does this mean? This means that in dynamically typed languages, like Ruby or JavaScript or whatever, in these languages, you are not specifying the type of something. So when you're constructing a method and the method takes an argument, you are not stating explicitly, you're not telling the compiler or the interpreter what that method is expecting, what that method is expecting in terms of the type of the argument. You are simply saying that it wants to receive something, and then you go about calling methods on that thing that it accepts. So that means that when you are receiving that concrete object as an argument, you are expecting it to behave according to some particular specification. Or put more lightly, you are expecting it to respond to a certain set of methods. So from a very pragmatic point of view, we could then say that duck typing is really nothing more than polymorphism without the hierarchy. So it's dynamic dispatch without inheritance hierarchy, or without explicit interfaces. So in other words, in a statically typed language, such as C# or Java, I'm now ignoring the keyword dynamic, but classically, in a statically typed language such as C# or Java, in order to achieve dynamic dispatch, i.e. call a method on an object whose type is not known at compile time, or I should say whose subtype is not known at compile time, essentially you have to either create a common ancestor or construct an interface. You have to somehow explicitly tell the compiler that you are expecting something that adheres to a specific specification, right? To a specific interface that responds to a certain set of methods, and then you can treat it as such. So returning to a classical animal example, right? You would say that your method takes something of type animal, and then you would have children that are subclasses of that parent class animal. So you could have lion and cat and dog, and consequently that means that the method that takes animals can also take lions or dogs or cats. But returning to the concept of duck typing. So duck typing says that it doesn't matter whether a lion is an animal or whether a cat is an animal. What matters is that it responds to the methods that we want it to respond to. So in dynamic languages, you can pass any object anywhere, and if the object does respond to the methods that you do want to call upon it, then that object does pass the duck test. In some sense, then, it is a duck because it per se did respond to the methods that make it a duck. So to push this one step further and think about the practical consequences of duck typing, people argue that you should not perform type checking. Type checking is in many senses considered a code smell. We'll talk about that in a separate video. But assuming that you buy that, that has interesting consequences for duck typing. So because in dynamic languages, you don't know what the type is of things that you are receiving. And it may be, at runtime, it may prove to be of any type. So how to make sure that you are not calling methods on, or that you are not calling quack, for example, when given something that is not a duck. So naively, we oftentimes resort to type checking. But the strong followers of duck typing, the way I understand it, would instead argue that you should not check for what something is, but you should check for what something is capable of doing, if you should check at all. But assuming that we need to determine whether we can perform some particular action on some particular object or not, then you should check for that capability, and you should not check for the type, knowing that that type does have that capability. To understand this, let's consider an analogy. If you're familiar with the concept of responsive web design, you've probably already come in contact with this concept of not trying to determine what something is, but instead focusing on what something is capable of doing. So in responsive web design, the idea is that there are so many devices out there. There are cell phones and tablets and computers and tons of different browsers and different versions, and like they're just accumulating as the years go by. So the point is that instead of trying to check in which particular environment your application is running, right? The argument is that that will bring you down a path of madness because there are just so many. So we're just going to have to create more conditionals and more conditionals and more conditionals and keep on checking for different types. So the argument is that you instead should be checking for capabilities. So instead of determining whether the environment you are running in is an old browser, for example, because you have some knowledge about what that particular browser does or does not support, you should instead check for the capability of performing the thing that you actually want to perform, and then making a decision based on that. So similarly for duck typing, instead of switching on a bunch of types that may or may not hit your application at that particular point of the code, you should instead switch on the things that you are actually aiming to use, if you are intending to switch at all. In order to nail this down one last time, the concept of duck typing is to not use information about what something is in order to determine suitability for a particular purpose, but rather to use capability as a way of determining whether it's suitable or not suitable for performing that particular purpose. So that's it about duck typing. If you find my explanation completely and utterly confusing, please do let me know and we'll dig further into this. And as usual, if you want more programming talks like this, be sure to subscribe.